Okay, so today we're going to look at sectors of circles. So we're just going to look at basic revision of circles and sectors of circles. So perimeter, okay, so that's the circumference of a circle. The formula is, which is interrogatives, is 2 pi r. The area of a circle is pi r squared. A Sidley quadrilateral is a quadrilateral inscribed in a circle. And then every triangle inscribed in a semicircle is a right angle triangle. So these are just our proofs that we would have learned from junior cert higher level. There's 360 degrees in a circle, which is also the same as saying 2 radians. Okay, and we touched on radians when we were doing complex numbers. What I have here is I have the arc of a circle, okay? Right, so this is my entire circle. My arc is just this part here, okay? So the outside, okay, so that's my arc, okay? And that's my minor arc, okay? So it's my small arc, and whereas the rest of the arc outside here, that's my major arc, okay? So if I want to get like a little part of this here, okay, I would say that the length of the arc is 2 pi r, okay, because that's my circumference formula, multiplied by theta over 360, because it's just a sector here, okay? Or you could also say 2 pi r by theta over 2 pi. That's because that's in radians, this is in degrees, okay? So the 2 pi is the same as 360. So there's just two different ways that we would do it. I would imagine that most of us will be using degrees, okay? The next page then we have is the area, okay? So this is the area of a sector. So the area of a sector is, your formula for the area of a circle is pi r squared, okay? If it's a sector, it's multiplied by theta over 360, okay? Or you could say theta over 2 pi if it's in radians, but we'll be using degrees also. I just want you to be able to recognise if it is in radians. We know that pi is actually equal to 180 degrees. Alright, here I have an example, okay? So I'm told a flower bed in the shape of a sector of a circle is placed in the centre of a rectangular lawn as shown in the diagram. I've one on the next page. I'm asked to calculate the length, okay, so we're going to be using my length formula, my circumference, of the edging needed for the flower bed, and I'm asked to calculate the area of grass in the garden correct to 1 decimal place. Okay, so that's what I have to do first for this particular question. Okay, so the diagram actually looks something like this. Okay, so this is my lawn, okay, it's rectangular, and this is my sector, okay, and then it's here again, okay. Right, so I have to get the length of the large sector IH, okay, so I'm going to get this sector here first of all, okay. Right, so my length is 2 pi r multiplied by theta over 360. Right, in the question it does show me that this here is 90 degrees, okay, so that's the theta that we're going to be using, okay. So what I have is 2 pi r, okay, is 8 multiplied by 90 over 360, which is equal to 4 pi, okay. My radius, okay, because we're doing a sector of a circle, it's from here to here, so it's 3 plus 5, and that gives me 8, so that's why I get my radius of that particular sector to be 8. My length of my small arc then, okay, so from J to K. So I'm just after finding the length from the here to here. Remember, it's really important, girls, that you realise when you're getting the length of an arc, you're only actually getting this part here. You're not including your radius at all, okay? So we're getting the length from here to here. That's what we did by getting 2 pi r multiplied by theta over 360, okay? My radius from here to here, okay, so it's 3 plus 5. My radius is 8, okay? Then I will need to get the length of my small arc, so from here to here, okay, so my angle is still at 90 degrees, okay, but this time my radius is just going to be 3, okay, so I'll go off and go and do 2 pi r, so r in this case is 3, multiplied by my angle is still 90 over 360, and then when I multiply this in, I get 3 over 2 pi meters, okay. Right, so my length of my arc altogether, so I've worked out that my I to H is 4 pi, plus my J to K is 3 over 2. Right, what I was trying to state earlier, that when you're finding your length, you're only actually finding this part and this part, right? So we found out, okay, so this here is all my flower beds, there's flowers all in that, okay, right, we found out the length from here to here, that's 4 pi, and the length from here to here is 3 over 2 pi, but we haven't calculated this in, or this in here, Okay, so from here to here is 5. That means from here to here is also going to be 5. So it's going to be 2 multiplied by 5. So then my total length of that sector of that flower bed is going to be 27.3 meters. The next part of this question asks me to get the area of the sector, okay, so the flower bed. So I have to get the area of the large sector, take away the area of the smaller sector. Right, so the area of my large sector, okay, so my formula for the area of a circle is pi r squared. For the area of a sector is pi r squared multiplied by theta over 360. Right, so pi, my radius is still 8 for my large sector, to be squared multiplied by my angle is still 90 over 360. Take away my small sector, so it's pi multiplied by 3. My radius is 3 to be squared multiplied by 90 over 360, and I get my area of my sector is 43.197 meters squared. Right, I'm asked, okay, to find out how much grass is actually needed, how much grass is in this question, okay? So I basically have my area of my rectangle is my entire lawn, but we need to remember that some of the flower bed is already taken up in this, okay? So my area of my rectangle is going to be 8 multiplied by 16, and that gives me 128 meters squared. So my area of my grass is my area of my rectangle, which is 128. Take away my flower bed area, which is 43.197. That gives me that the area of the grass is actually 84.8 meters to be squared, and I found that out by, okay, so if you look at the diagram again, okay, I know that my radius from here to here is 8, okay, right, so that means that my radius from here to here must also be 8, so this length here has to be 8 meters, and if from here to here is 8, okay, and from here to here also has to be 8, so the full way across has to be 16 meters. That's why I found the area of my rectangle, okay? So I found the area of my larger sector and the area of my smaller sector, and I took that away from each other, and then I found the area of the grass that's left outside here. And that's what I did for that particular question. Okay, so here I have another question. So it says a minor arc CD of a circle, centre O and radius 20 centimeters, subtends an angle X, so subtends means to create, an angle X radians at O. The major arc CD of the circle subtends an angle 5x radians at O. Find in terms of pi the length of the minor arc. Right, so just drawing out a diagram here, okay? So this is my circle, centre is O, okay? Right, so my minor arc CD, so my small arc CD, we're told that it has a radius of 20, okay? So this is my radius of 20, and we're also told that it creates an angle of X. Okay, right, and then I'm told that my major arc, which is all out here, it creates an angle or subtends an angle of 5x. Okay, right, so my CD, okay, so my arc CD is equal to r theta. Okay, right, so r theta, so my radius by the angle, okay, and that's equal to 20x. Okay, and then my major arc is equal to r theta, and that's equal to 20 by 5x. Okay, and that's 100x. So the major arc, okay, so the length of it is 2 pi r minus my minor arc. Okay, so because the circumference is equal to 2 pi r, that's why I use 2 pi r there. Okay, so my full circumference would be equal to 2 pi r minus my minor arc is just my small arc here, my CD. Right, so I know that my major arc, okay, my 2 pi r, okay, is equal to 100x. Okay, right, so 100x is equal to 2 pi, my radius is 20, minus my minor arc we worked out up here is 20x. So then I have here, okay, so 100x is equal to 40 pi minus 20x. So then I bring over my 20x and becomes 120x is equal to 40 pi. So I get x is equal to 40 pi over 120, and then when I put that into the calculator, I get x is equal to pi over 3. So my minor arc CD is equal to 20x. So we just figured out that x is pi over 3. So 20 times pi over 3 gives me 20 pi over 3. centimeters. So that's the second example done. Now I have more questions here. Okay, so here I'm given another flower bed, and I'm told that this is 80 degrees. From here to here is 7, and from here to here is 3. So I'm asked to get the perimeter of the bed. That's the same way as getting the circumference, and I'm asked to get the area of the bed. So I'm dealing with a sector of a circle, basically, girls. Okay, right, so the perimeter of the bed, okay, so it's going to be 80 over 360 multiplied by 2 pi. My radius from here to here is 7, plus, okay, then I need to get my area. So we're basically after finding out this part here. Okay, so 80 over 360 by 2 pi, or, okay, my radius from here to here is 7. Okay, so we're dealing with this part. Now we're getting plus 80 over 360 multiplied by 2 pi, and then my radius from here to here is 10. So we're finding out what this part is worth here. Okay, so I get that when I do all that, I get that the perimeter of the bed, okay, so we've got from here is 23.73. Okay, but we can't forget we need to add on the 3 here and the 3 here. So I said plus 6 centimeters, so it gives me 29.7 centimeters. Okay, like the last question we did, okay, so we'll find the area. Okay, so the area is pi r squared. Okay, so it's going to be the larger area minus my smaller area to find out what is my area of my flower bed. So it's 80 over 360 multiplied by pi. My radius is 10 of my larger one to be squared, minus 80 over 360 multiplied by pi. My radius is 7 of my smaller one. Okay, and my answer for my area is 35.6 centimeters to be squared. Now what I have is I have a semicircle and I have a triangle. Okay, so here it tells me that my perpendicular height is 12 centimeters and my length the whole way across is 8 centimeters. So I can basically say that this is my diameter, this is 8, okay, and that means that my radius has to be 4. Okay, right, so I'm asked to find the total area correct to the nearest centimeter squared, and I'm asked to find the total perimeter enclosed by this composite figure correct to the nearest centimeter. Right, so the first thing I'm going to do is I'm going to get the area of my semicircle. Okay, so the area of a semicircle, it's a sector. Okay, so what I need to do is I need to know my angle, I need to know my radius. Okay, right, so the area is going to be equal to pi r squared multiplied by theta over 360. My radius in this case is just going to be 4 centimeters. So it's pi 4 to be squared multiplied by, okay, we're only dealing with half a circle, so it's 180. So 180 multiplied by 360. Okay, so my area of my semicircle is going to be 25.1327. So I now have the area of my semicircle, but I need to get the area of my triangle. So the formula for an area of triangle is half the base by the perpendicular height. Okay, right, so half, my base the whole way across was 8, so it's half of 8 multiplied by my perpendicular height is 12, and that gives me 48. Okay, so my total then is 48 plus, okay, the area of the semicircle, which we just figured out, and we get that is 73.1327, but we were asked correct to the nearest centimetre, so it's 73 centimetres squared. Then I'm asked to get the perimeter of this shape. Okay, so that's my circumference. I need to get the circumference of this shape, and I need to get this length and this length here. Okay, so the first thing I'm going to do is I'm going to get my semicircle. So my formula for my perimeter of a sector is 2 pi r multiplied by theta over 360. Because we're dealing with half a circle, the half a circle is 180, so that's 180 over 360. My radius is still 4 centimeters, so it's 2 pi by 4, and I get the perimeter, so from here to here is 12.566. Right, I know that this way is 8, okay, but I know that the perpendicular height is 12, but I don't know what its slant height is, okay? So I just draw a diagram. I'm basically just splitting this down the centre here, okay? So what I have is I have this here is going to be 4 centimeters, this is going to be 4 centimeters, so I have 4 centimeters, okay, and my perpendicular height is 12 centimeters, and I'm looking for the slant height. So looking for my slant height, this is my radius, this is my perpendicular height, and this is what I'm looking for. Right, I'm missing a side, so that means I need to use Pythagoras' theorem. So a squared plus b squared is equal to c squared. So I have my a is 4 to be squared plus 12 to be squared is equal to my c to be squared, or you could say x to be squared. Squared is 16 plus 144, and that's equal to c to be squared. So I get 160 is equal to c squared, so c is equal to root 160. Right, so that basically tells me that this is root 160, and that means that up here is also root 160, okay? So I go that the perimeter of this entire shape is going to be 12.566, so that's what we found out that our semicircle was, plus root 160 plus root 160, and that's equal to 38 centimeters then when I add it up together. Okay, so these particular questions then ask me to write a formula for each of the following shaded areas. Okay, so I'm given a semicircle here. It is shaded. So I need to write a formula for the areas of all this. So this is a circle, okay, well, a semicircle. So the area of a semicircle is going to be pi r squared multiplied by, because we're dealing with half a circle, it's 180 over 360. So I just get that it's pi r squared over 2. Okay, the next one then, I have a small circle here, and it's inside a bigger circle, and I need to get a formula for the area of just outside here. Okay, right, so I'm basically being told that the centre from here to here, the radius is a capital R, and for the smaller circle, the radius is just a small r. Okay, so the area of a circle for the larger circle is pi capital R to be squared, and then I need to take away the area of the smaller circle, so that's minus my pi r squared. I'm just factorising this as if it's algebra now. So I take out my pi, and I'm left with r squared, capital R squared, minus r squared, small r squared. And that's the area of that particular question. Now I have another one. Okay, so my diagram isn't the best, but I have sent on the actual questions to you. Okay, so I'm basically being told it's a square with a circle after being cut out, okay, because this is equal to this and this is equal to this, okay? So I need to get the area of the square, take away the area of a circle, okay, because we have, if we joined all this up together, it definitely makes up a circle. Okay, so if I actually look at this before I go on and show you how to get the area of the square, from here to here is a, right, if this is equal, that means that all these sides here are also x, so this has to be x, this is x, this is x, okay? This has to be a here. Okay, because the length of all my semicircles is equal to a. So a full side here is going to be 2a plus x. Okay, and then we know the area of the square is going to be length to be squared. Okay, so the area of my square then is going to be x plus 2a to be squared minus pi. My radius is a to be squared, so that's my formula then. Okay, part D looks something like this. So it's a rectangle with a semicircle here and a semicircle here. So we know two semicircles make up a circle. So the area is equal to the area of the rectangle plus the area of a circle. Right, so if I take this out, okay, so this is going to be A, this is B. So my area of my rectangle is just AB. And then my area of my circle, okay, so my diameter here is A. That means that my radius is A over 2. Okay, so my radius of my circle is going to be pi r to be squared, and that's a over 2 to be squared. So my area of this particular shape is ab plus pi a squared over 4. Okay, so the next one here is a triangle, and the base is a, and the slant height is x, and I'm told that it is an isosceles triangle because two sides are equal here. Right, I know that the area of a triangle is half the base multiplied by the perpendicular height, but I don't know what my perpendicular height is. So, I draw out a diagram. Okay, right, so I'm after splitting this down the centre. So that means that my base is going to be a over 2. Okay, right, so what I have here is this is my right angle, okay, so this is x, okay, so opposite my right angle is x. I don't know what my question mark, I just put it here, or I could call it h because I am looking for my perpendicular height, okay. So what I do is I say a squared plus b squared is equal to c squared, because we're dealing with Pythagoras' theorem because it's a right angle triangle. Right, so a to be squared is going to be a over 2 to be squared, plus my b, I called it h to be squared, is equal to x squared. Right, so a over 2 to be squared is a squared over 4 plus h squared, and that's equal to x squared. Right, so I know then that x is equal to the square root of a over 2 plus h. But that's no good to me because I wanted to know what was my height, okay? So I go h squared, I just rearrange it, okay? So h squared is equal to x squared minus, I bring over my a squared over 4, and it becomes minus a squared over 4. So I get h is equal to the square root of this, okay? So this is what my height is equal to. Alright, so then my formula, filling it in, my area is equal to half the base by the perpendicular height, okay? So it's half, my base was a, multiplied by my perpendicular height. We just figured out this formula there. Okay. This is another example, okay? Right, so in this example, I'm told that my base here is A. I'm given these 3 lines. So I'm basically being told that it's an equilateral triangle, and we know an equilateral triangle has 3 equal sides and 3 equal angles, and the angles have to be equal to 60 degrees, okay? Right, so to get the area of this triangle, I'm going to go half AB sine C, okay? So what I did is I did half A. So this is going to be A, and my B is going to be A, and sine, my angle is going to be 60 because all these angles are 60 degrees, okay? So I have a half, A by A is A squared sine 60. Right, so I have A squared over 2 times sine 60 is root 3 over 2, and then when I multiply this out, I get root 3 A squared all over 4. Okay, right, here I have another sector, okay, so I have that my radius here is r, my radius is r, this is my angle, and we call it theta, and as previous, this is going to be r theta, this part, okay, my arc. Right, so my perimeter is going to be r theta, okay, plus r, right, so my perimeter is equal to r, I'm just factorizing, and I take out r, and it's 2 plus theta. Okay, then my radius is equal to p over 2 plus theta. Okay, question 5 then. I have this here, okay, so it's drawn out, okay, so I drew it out like this first of all, but this way I'm going to draw it out here to make more sense to us, okay, so this is my arc S, T, this is standing on the same arc T, so I have angle RTS is equal to 0.4 radians. I was given that information, okay, so angle RTS, okay, is equal to 0.4 radians, and I know that angle ROS, okay, so angle ROS is equal to twice the angle RTS, okay, because remember that the angle subtended from the diameter, or from the semicircle, okay, so this angle here is always going to be twice the size of the angle that it subtends, okay, so that's why this angle here is twice this angle up here, okay, so if this was 60 degrees, then this here would be 30 and so on, okay, so that's a theorem that you would have learned in junior cert, okay, so then twice of 0.4 will give me 0.8 radians. So then my distance from R to S is going to be 8.5 because that was my radius multiplied by 0.8, and it gives me 0.6, it gives me 6.8 centimeters. Okay, question 6 then asks me, okay, so question 6 says that a square is inscribed inside a circle of radius R. Find the area of the square BCDE and the shaded area in terms of R. Okay, right, so I'm basically after being told that the circle has a radius of R, and I want to find the area of a square. Okay, right, so what I have there, I'm after taking out, okay, right, so this is my circle and I have my radius, okay, so this is my radius of my circle, this is my other radius, okay, I don't know what my length of my square is, and I know that all 4 sides in a square are equal, okay, so I just created, okay, so I'm doing Pythagoras' theorem, okay, right, so L squared is equal to R squared plus R squared, okay, and then what I have is I have L is equal to 2 root R, okay, so that's what I found out that L is equal to, and we know that the area of a square is equal to L to be squared, so it's going to be 2 R squared is the area of a square, and then the area of the shaded section is going to be the area of the circle, take away the area of the square, divided by 4, because these are all going to be equal. My diagram isn't great, but if you look at the PowerPoint, it's much better. Okay, so these are all actually equal to one another. So then when I have my area of my circle is pi r squared, minus my area of my square is 2r squared all over 4. So it's going to be, and I was asked to leave it in terms of r, so I need to have my r outside. So it's going to be r squared over 4 bracket pi minus 2. And that's why I got that one. So for question 7, it tells me that a farmer has 80 metres of fencing to make a circular chicken coop. Find the radius and the area of the coop to a suitable degree of accuracy. Explain why the radius cannot be measured with complete accuracy. Okay, right, so I just drew out a rough diagram here. We weren't given one. Okay, so basically it has to be a circular fence. Okay, and I'm told that he has 80 metres of fencing. Okay, so my 80 metres of fencing, and because I'm dealing with the perimeter, my formula is 2 pi r. So I get that I want to get r on its own, so I go r is equal to 2 pi divided by 80. And then I get r is equal to 12.73 centimetres squared. And the reason why is because it would be too difficult to get a radius of 12.73 centimetres to be squared. Then what I did to get my area of that particular shape is I had to find the area of the shape here. So it says find the ratio of the area of the inner square to the area of the outer space. Oh, sorry, I think I'm actually after skipping on to the next one. But my area is pi r squared, so my area is equal to pi, the radius to be squared, and that's equal to 509.30 centimetres squared. Okay, question 8 then, it tells me, okay, so what I have here in question 8 is I'm told that the circle is shown with both an inscribed and a circumscribed square. Find the ratio of the area of the inner square to the area of the outer square. Okay, right, the first thing I'm going to do is I'm going to let the circle have a radius of r. Okay, right, so the radius from the centre to here and the radius from the centre to here, right? Then what I need to do is I need to find the area of the outer square. Okay, so if from here to here is my radius and that's r, then from here to here is another radius. So the whole length here has to be 2r. It'll be 2r, which will give me 4r to be squared. And then I need to go on and actually find the area of the smaller square. But what I need to do is I need to figure out what is my length of my square going to be. So it's similar to the example we done already. Okay, so we're looking for my length. Okay, so it's going to be length to be squared is equal to r squared plus r squared. So it's L squared is equal to 2r squared. So L is equal to 2 root r. So the area of the inner square is going to be LL, which is going to be, so length multiplied by length, which we know that L is 2 root r, so it's 2 root r times 2 root r, which is equal to 2r squared. So the ratio of the area of the outer to the inner is 2r squared is to 4r squared, and then divide across by r squared I get 2 is to 4, which is the same as 1 is to 2. And that's question 8 completed. Part 2 of this question, it says an equilateral triangle is shown with both an inscribed and a circumscribed circle. Calculate the ratio of the area of the circumcircle to the area of the incircle. Okay, so we should also know how to do this construction. Okay, but basically what we have is I'm going to say that my radius of my small, okay, so from here to here is going to be r, and then I'm going to say that the radius from my larger circle is going to be a capital R. Okay, so my small circle we call it R, and my large circle we call it capital R. We know that it's an equilateral triangle, so that means that the angles are all 60 degrees. Okay, so what I'm after doing is I'm after creating a right angle triangle here, and this is going to be my angle. I'm after bisecting it here. Okay, right, so this here, because we'll just say that this is a tangent to my particular circle, it only has one point of contact. Okay, so I'd say sine 30 is equal to my opposite over my hypotenuse. My opposite is r, my hypotenuse opposite my right angle is capital R. So then r is equal to r sine 30 degrees, so r is equal to r, sine 30 is a half, so r is equal to r over 2. Right, so then the area of the circumcircle to the area of the incircle. Okay, so the area of my circumcircle is pi r squared, and then the area of my smaller circle is pi r small r to be squared. So I have pi r squared is to pi. We just figured out that r is equal to r over 2, so r over 2 to be squared, so that's going to be r squared over 4, so it's going to then be divided across by pi r squared, and I get 1 is to a quarter, so then the ratio is 4 is to 1. Question 9 then tells me that a circle of circumference 12 centimeters is inscribed in a square, and which in turn is inscribed to an outer circle. The outer circle touches the parallel sides of a trapezium as shown. Find the area of a trapezium given your answer in the form a root b over pi. Okay, right. Area of trapezium, this is in my log tables, is just a plus b over 2 times perpendicular height. Okay, so 2 plus 5 over 2 times my height, I don't know yet. Okay, right? So, but what I do know is that my height is going to be 2r. Okay, because from here to here is my radius, but also from here to here is my radius, so it's going to be 2r. And I'm told that that height was 12. I'm told it at the very start of the question. So I'm told that given 12 is equal to 2 pi r, okay, so my length, okay, of my circumference. So r then is equal to 12 over 2 pi. So I get r is equal to 6 pi. And then I have r squared is equal to 6 over pi to be squared plus 6 over pi to be squared, which gives me 72 over pi squared. So then r is equal to root 72 over pi to be squared, which is, when I break it down into my calculator, is 6 root 2 over pi. So then my area of my trapezium, okay, so we've already figured out this, okay, and then here I have 6 root 2 pi, okay, so 2 times this, and then I have 42 root 2 over pi. And that's question 9 completed. Here I have then question 10. So question 10 says, the shaded portion of the semicircle is to be cut from a large sheet of metal. Write down its in radians the measure of the angle AOB. Find the exact length of the perimeter of the shaded portion. Find the area of the shaded portion, and hence find the area of the non-shaded segment. Okay, right, so angle AOB, okay, so AOB, so this part here is equal to, right, so full rotation, full 180s is pi, so minus 2 pi over 3, so that gives me pi over 3, and that's the same as 60 degrees, okay? And then I'm asked to find the exact length of the perimeter of the shaded portion, okay? Right, so angle AOB, okay, so, or OAB, so angle OAB, okay, so this angle here is equal to angle ABO, okay, so this angle is equal to this angle because it's an isosceles triangle, okay? So then I can say the angle OAB is equal to 60 degrees, okay, and that's equal to angle ABO. AB, okay, is then we can say it's equal to r, okay, so the circumference is equal to AB plus 2BO plus the sector, okay. So then I have AB is 2 plus 2 times BO, so 2 times 2, plus 2 times my sector then, okay, so 2 pi over 3, okay, and I have 6 plus 4 pi over 3, and then my area is equal to, that's the wrong one second. So I was asked to get the area of the shape, okay, so it's the area of the triangle plus the area of the sector. So an area of triangle is half, so half AB sine C, so half 2 sine, my angle is 60 degrees, plus the area of my sector, so half 2 pi over 3, so it's 2 by root 3 over 2 plus 4 pi over 3. So when I multiply this out, I get root 3 plus 4 pi over 3. My area of my non-shaded is going to be the area of the semicircle, take away my area of the part that's shaded, okay, which we just figured out there. So it's pi r squared over 2, okay, so so it's pi, my radius is 2 to be squared because the semicircle is divided by 2. Take away what we just found out was the shaded area, so it's 2 pi minus 4 pi minus root 3, and we just get 2 pi over 3 minus root 3, and that's it completed.